Now this paper contain total 2 questions. Question number 2C with option and question number 3C with option. ओके, तो स्टूडेंट को ये दोनों में से कोई भी एक क्वेश्चन सॉल्व करना है. सेम वे ये दोनों में से कोई एक क्वेश्चन सॉल्व करना है. ओके, सो नाउ द वेटेज इज व्हाट? Here 7 marks. Again question number 3C contain 7 marks. Okay, so what is the total weightage? From this paper student can score 14 marks only from infinite series. Okay, so now let's discuss each example one by one. In this lecture, solution of question number 2C is given. Question 2C. Define geometric series and explain its convergence. Test the convergence for the following series. First series, summation n is 1 to infinity 1 upon 4n square minus 1. And the second sum is summation n is 0 to infinity 2 raised to n by 2. So, first of all, we will discuss definition of geometric series. Definition: a geometric series is a series of the form summation n is 0 to infinity ar raised to n. Now put n equal to 0, so we get first term a. Put n equal to 1, so we get second term ar. Put n equal to 2, so we get third term ar square, and so on. So this is the general form of the geometric series. In this series, a is what? A is the first term and R is common ratio. Why it is known as common ratio? Because if each term is divided by the previous term, then these R remain common. Okay, let's check. Now second term AR is divided by first term A. Okay, so what we get? R. Now third term AR square is again divided by the previous term. Previous term is what? AR. So again what we get? R, and so on. Okay, so here if each term is divided by the previous term, we get R. Okay, so this is known as common ratio. So if we have a knowledge of R, on that base we can find the convergence and divergence of the geometric series. So now let's discuss. The above geometric series converges if mod r is less than 1. Now mod r is less than 1 means minus 1 less than r less than 1. Okay, so for this value of r, the geometric series is convergent. And if the series is convergent, then what is the sum of the series? The sum of the series is S is equal to A upon 1 minus R. Okay, where A is the first term and R is the ratio. Okay, so if we have a knowledge of first term and ratio, we can find the sum of the series. Okay, next, if mod R is greater than or equal to 1, okay, then what is the mod R is greater than or equal to 1, then the series diverges. Okay, means minus 1 greater than or equal to R greater than or equal to 1. Okay, so in this range the geometric series is divergent series. Okay, so now from the knowledge of R, we can easily find the convergence of the geometric series. Convergence of the series 1 upon 4n square minus 1. Now here in this sum only convergence is asked. Okay, ये सम में हमें क्या करना है? सिर्फ कन्वर्जेंस ही चेक करना है. यहाँ पे हमें सम फाइंड नहीं करना है. ओके, सम इज नॉट आस्क. ओके, सो दैट्स व्हाई टू सॉल्व दिस सीरीज वी यूज लिमिट कंपैरिजन टेस्ट. Why limit comparison test? Because here 4n square minus 1, this one is a what? This one is a polynomial in R and say yes or no? Okay, so polynomial in n. So that's why we can take n common. So to find the convergence of this series, limit comparison test is applied. Okay, लिमिट कंपैरिजन टेस्ट से हम इजीली इसका कन्वर्जेंस फाइंड कर सकते हैं. सो नाउ फर्स्ट हियर वी आर डिस्कसिंग हाउ टू अप्लाई लिमिट कंपैरिजन टेस्ट. फॉर लिमिट कंपैरिजन टेस्ट, फर्स्ट ऑफ ऑल we have series AN. Okay, so given series is what? Series AN. Series AN is given to us. Now for this given series AN, or we can say AN series के साथ कंपेयर करके हम एक न्यू सीरीज BN फाइंड करेंगे. ओके, सो फाइंड सीरीज BN. नाउ व्हाट इज द थर्ड स्टेप? फाइंड द लिमिट L. Limit L is equal to limit n tends to infinity AN upon BN. If this limit value lie in this range 0 less than L less than infinity, or we can say L is what? Some finite number except 0, then we conclude series AN and series BN both converge or both diverge together. So what does it mean? So it means if series BN converges, then series AN also converges, and if series BN diverges, then series AN also diverges. Okay, so for this purpose, next what we need? We need the convergent of series BN. Okay, next हम क्या फाइंड करेंगे? सीरीज BN का कन्वर्जेंट. क्योंकि ये टेस्ट से हमें क्या पता चला कि सीरीज BN और सीरीज AN का कन्वर्जेंस और डाइवर्जेंस क्या है? सेम है. ओके, और अगर हम BN सीरीज का कन्वर्जेंट फाइंड कर लेते हैं तो जो BN का कन्वर्जेंट होगा वो ही AN का होगा. ओके, सो दैट्स व्हाई नेक्स्ट इज व्हाट? फाइंड द कन्वर्जेंस ऑफ सीरीज BN. अगर हमारी BN सीरीज कन्वर्जेंट है तो AN भी कन्वर्जेंट होगी, और अगर BN डाइवर्जेंट है तो AN भी क्या होगी? डाइवर्जेंट होगी. ओके, सो नाउ लेट्स स्टार्ट. फर्स्ट ऑफ ऑल, दिस इज द गिवन सीरीज. Summation n is 1 to infinity 1 upon 4n square minus 1. Okay, so this is what? This one is my given series AN. Okay, now what is AN? AN is what? Nth number of term of this series. So AN is 1 upon 4n square minus 1. Okay, so now first step, what is? Find series BN. So comparing this series AN, find new series BN. So how to find series BN? First of all, observe the maximum power of n in numerator. So here what is the maximum power of n? N raised to 0. Okay, in numerator. So that's why here write n raised to 0. In denominator, what is the maximum power of n? N square. Okay, so n raised to 0 means 1 and n square as it is. So new series BN is what? 1 upon n square. Okay, so here new series BN we can find by comparing it with series AN. Okay, मतलब कि BN सीरीज को हमने कैसे फाइंड किया? AN के साथ कंपेयर करके. Okay, so that's why the name is what? Comparison test. So now next step, apply limit comparison test. So here, as per the discussion here, find limit L. L is equal to limit n tends to infinity AN upon BN. So what is the AN? AN is nth number of term of the given series 1 upon 4n square minus 1, and BN is what? Nth term of the new series. This is 1 upon n square. Okay, so now simplify this. So what we get? 1 upon 4n square minus 1 multiply. Now reverse the denominator and numerator, so we get n square upon 1. Okay, so now we have n square upon, now from denominator take n square common, so 4 minus 1 upon n square. Okay, so now n square is cancelled out, and now apply limit n tends to infinity, so this term become what? 0. So what is the answer? what we get? Answer is 1 upon 4. And what is 1 upon 4? 1 upon 4 is nothing but finite and non-zero. Okay. So that's why from limit comparison test we conclude series AN and series BN both converge or diverge together. ओके मतलब कि सीरीज AN और BN का कन्वर्जेंस और डाइवर्जेंस क्या है? सेम है. ओके. नेक्स्ट, फाइंड कन्वर्जेंस ऑफ सीरीज BN. ओके, सो व्हाट इज द BN सीरीज? हियर BN series is what? Series 1 upon n square. Okay. So now this series is what? P series. What is the form of P series? Series 1 upon n raised to P. Okay. Now the condition is that if P is greater than 1, then the P series is convergent series. And if P is less than or equal to 1, then the P series is divergent series. Okay. So now here compare with P series. So what is my P here? P equal to 2. Okay. And 2 is greater than 1. So from this condition, the given series is what? Convergent series. Okay. So now here what we conclude? BN series is convergent series. And as per the limit comparison test, here what we conclude from limit comparison test, series AN and series BN both converge or diverge together. Okay. तो मतलब कि अगर सीरीज BN convergent है तो AN भी convergent है. Say yes or no? So that's why what is my conclusion? The conclusion is, since the series BN 1 upon n square is convergent, by the limit comparison test, the series AN equal to 1 upon 4n square minus 1 is also convergent. Question 2. Second question. Test the convergence of the series summation n is 0 to infinity 2 raised to n by 2. Okay. So now अब ये सीरीज का कन्वर्जेंस हमें चेक करना है. ओके. तो पहले हम ये डिस्कस करेंगे कि यहाँ पे कौन सा टेस्ट यूज होगा. तो यहाँ पे हमारे पास क्या है? 2 raised to n by 2 मीन्स पावर ऑफ n इज गिवन. तो इफ पावर ऑफ n इज गिवन, वी कैन यूज आइदर रेशियो टेस्ट और वी कैन यूज रूट टेस्ट. ओके. लेकिन हम यहाँ पे कौन सा टेस्ट यूज करेंगे ये दोनों में से? तो For this, check the definition of root test. Okay. तो root test की definition क्या है? L is equal to limit n tends to infinity nth root of mod an. Okay. मतलब कि हम यहाँ पे nth root of term ले रहे हैं. तो अगर हम nth रूट लेके n को इजीली रिमूव कर सकते हैं तो हमें क्या यूज करना है? रूट टेस्ट. ओके. सो नाउ व्हाट इज द कंडीशन फॉर दिस? इफ L इज लेस देन 1, देन व्हाट वी कंक्लूड? द गिवन सीरीज इज कन्वर्जेंट सीरीज. इफ L इज ग्रेटर देन 1, देन द गिवन सीरीज इज डाइवर्जेंट सीरीज. एंड इफ L इक्वल टू 1, देन दिस टेस्ट इज इनकंक्लूसिव. मतलब कि हम L इक्वल टू 1 के लिए कुछ भी कंक्लूजन नहीं दे सकते. ओके. सो मीन्स द टेस्ट इज फेल. ओके. सो नाउ लेट स्टार्ट. लेट AN is equal to 2 raised to n by 2. This is my nth number of term. Using the root test, we compute limit L is equal to limit n tends to infinity nth root of mod of an. Okay. So L equal to limit n tends to infinity nth root of, put an. So an is what? 2 raised to n by 2. This is the positive term. Okay. So after removing absolute value, again 2 raised to n by 2 remain as it is. Okay. So now evaluate this limit. So what we get? 2 raised to n by 2. Okay. And nth root means we can write 1 upon n. So this n is cancel out. We get 2 raised to 1 by 2. And 2 raised to 1 by 2 is nothing but root 2. Okay, so after applying limit n tends to infinity, we get root 2. So L equal to root 2, and as per the condition, if L is greater than 1, then the given series diverges by the root test. Okay, so here what we conclude? The given series is divergent series.